Happy morning, students. Welcome to Blue Star Sci Secondary School online classes, 10th standard physical science. So, previous class we have discussed about Unit 6 nuclear physics. So, there are two types of radioactivity, that is artificial and natural radioactivity. There are alpha, beta, and gamma. These are the natural radioactivity and the properties of alpha, beta, and gamma rays. Alpha decay, beta decay, gamma decay. These are the discussed about previous class. And nuclear fission. What is meant by nuclear fission? The heavier nucleus break into smaller nuclei. So these nuclei release the amount of energy. That is, a few neutrons is released. That is nuclear fission. Next, fissionable materials. A fissionable material is a radioactive element which undergoes fission in a sustained manner when it absorbs a neutron. So it is also termed as a fission material. So these are the discussed about previous classes. So in this class we have discussed about chain reaction. Okay. So a chain reaction is a self-propagating process in which the number of neutrons goes on multiplying rapidly, almost in a geometrical progression. Okay. So this is known as the chain reaction. For example, nucleus, that is uranium nucleus U-235, it is bombarded. So with a neutrons. So it undergoes the fission reaction. Okay. So at this process it produces a 3 neutrons. So these 3 neutrons again go to fission process and the uranium nucleus is divided into or produced into a 9 neutrons. Next, this 9 neutrons is again produce a 27 neutrons and take a fission reaction. So this is called chain reactions because first the 3 neutron is produce a next 9 neutrons and that 9 neutrons is produce a next 27 reactions. So this is form a or like a chain. So this reaction is called as chain reactions. So these are the two kinds of chain reaction are possible, that is controlled chain reaction and uncontrolled chain reaction. So chain reactions means that the number of neutrons is multiplied. It is a geometrical progression, that is 3, 9, 27, etc. So this is a geometrical. Okay, so this is means that chain reactions. The first one is controlled chain reaction. So in this controlled chain reaction, the number of neutrons released is maintained to be 1. This is achieved by absorbing the extra neutrons with a neutron absorber having only 1 neutron to produce further fissions. So controlled chain reactions, normally the chain reaction is produced a 3, 9, 27, etc. But controlled chain reaction first release the 3 neutrons at this process fissions. The 3 neutrons, next only 1 neutron is released. So this only 1 neutron is further moved to a fission reactions. Remaining neutrons are absorbed with the use of neutron absorber. Okay, so during the nuclear fission or fission process, many neutrons are released, but next fusion only 1 neutron is released. So remaining neutron is absorbed by a neutron absorber. So this is the controlled chain reaction. Okay. In this process, some amount of energy is released. So this energy is utilized by a constructive purpose. Okay. So the controlled chain reaction is also used in the nuclear reactor. So very useful to the this energy. Okay, this is the controlled chain reactions. The next type is uncontrolled chain reaction. In the uncontrolled chain reaction, the number of neutrons is multiplied indefinitely and causes a fission in a large amount of the fissile material. This results in the release of huge amount of energy within a fraction of a second. So at a during process of fission, a number of neutrons is released. கணக்கே இல்லாம என்ன ஆகும் நியூட்ரான்ஸ் வந்து எல்லாமே ரிலீஸ் ஆகும் ஓகேவா ஸோ அட் தி ப்ராசஸ் a large amount of energy is released at a fraction of or within a fraction of second. A huge amount of energy is released in the uncontrolled chain reaction. So this type of reactions, that is uncontrolled chain reaction, is used in the atom bomb. Okay, because explosion. This picture is indicate the uncontrolled chain reaction. So this is the first neutron generation. This is the called as the second neutron generation. This is the third neutron generation. Okay. So this is the controlled and uncontrolled chain reaction. So the uncontrolled chain reaction is used in the atom bomb. Okay. So the principle of atom bomb is the uncontrolled chain reaction. So in the uncontrolled chain reaction, the number of neutrons and the number of fission reactions multiply almost in a geometrical progression. This releases a huge amount of energy in a very small time interval and leads to an explosion. Okay. So all of you know that in 1945, Hiroshima and Nagasaki in Japan during the World War II. So this is the most important atom bomb explosion. It is affecting many people. All of you know that the Hiroshima and Nagasaki World War. Okay. So all of you know that in the uncontrolled chain reaction, huge amount of energy is released within a fraction of time. Okay. So same process. Atom bomb produce a large amount of energy. So this is the structure of the atom bomb. Okay. So this atom bomb consists of a piece of fissile material. This mass is subcritical. Okay. So this piece have a cylindrical void. Okay. So this is the cylindrical void. So the atom bomb have a cylindrical fissile material and void. So these two have a fixed. Okay. The cylindrical fissile material which can fit into the void and its mass is also subcritical. Okay. So the bomb is exploded. The cylinder is injected into the void using a conventional explosive. So the two pieces of fissile material join to form the supercritical mass which leads to an explosion. So the cylindrical and void, the cylindrical fissile material and the void, these two makes a supercritical mass. Okay, so this is the make a explosion. So this is the what is this remote control method atom bomb. So the atom bomb has a cylindrical fission material. It is fit to the void. So these two have a explosion. So During the explosion, huge amount of energy is released, that is heat, light and radiation. These are the energy. Heat energy, light energy and radiation, these are the released in the explosion time. Okay. So a region which place is atom bomb is explode, that region is very high temperature and pressure is formed in a fraction of second. Like this process, the gamma rays is released. So the gamma rays is affect the human beings or living things. So same process is in the 1945 Hiroshima and Nagasaki. So many people are dead because a high amount of heat energy, light energy, radiation are affected by the people. இன்னுமே என்னது அங்க இருக்கிறவங்களுக்கு பேபிஸ்லாம் பிறக்கிறப்ப என்னது அந்த தாக்கம் இன்னமும் இருக்கு அப்படின்னு சொல்றாங்க. ஓகேவா? குழந்தைங்கலாம் வந்து ஏதாவது ஒரு ப்ராப்ளமோட பிறக்கிறது அந்த மாதிரிலாம் இருக்கு. பிகாஸ் என்னது இந்த ஆட்டம் பாம் எக்ஸ்ப்ளோஷனால் தான் அந்த ஹியூமன் பீயிங் நிறைய பேர் என்ன பண்ணிருக்காங்க, அஃபெக்ட் ஆயிருக்காங்க. அந்த அஃபெக்ட் இன்னமும் கண்டினியூ ஆகின்னு இருக்கு அப்படின்னு சொல்றாங்க. ஓகேவா? அங்க இருக்கிறவங்களுக்கு இன்னமும் அந்த ப்ராப்ளம்ஸ் தொடர்ந்து கண்டினியூ ஆகினுக்குது. ஏன்னா அவங்க ஜீன்ல இருக்கும். அப்ப அந்த குழந்தை பிறக்கிறப்ப அவங்களுக்கே என்ன ஆகுது, அந்த ஜீன்ல இருந்து அவங்க அந்த குழந்தைங்களுக்கும் வருது அப்படின்னு சொல்லிட்டு ஓகேவா? ஸோ திஸ் இஸ் வெரி வெரி டேஞ்சரஸ் atom bomb. ஓகே. ஸோ தி எலக்ட்ரான் வோல்ட் இஸ் measured to use the nuclear physics to measure the energy of small particles, that is electron volt. So 1 electron volt equal to 1.602 into 10 power minus 19 joule. Okay. Otherwise, the 1 million electron volt equal to 1 mega electron volt. This is equal to 10 power 6 electron volt. Okay. So at the process nuclear fission, energy is at least about 200 million electron volt. Okay. At the process nuclear fission, the energy is released to 200 milli electron volt. So next one is critical mass. What is meant by critical mass? The rate of production of neutrons due to nuclear fission must be more than the rate of its loss. This can be achieved only when the size of the fissionable material is equal to a certain optimum value. This is known as critical mass. So, during the nuclear fission process, 3 or 2 neutrons are released. Okay, but these neutrons are not to produce a further fission or included at the further fission. Okay, so some of the neutrons are absorbed by the neutron absorber or escape from the system. So this is called as leakage of neutrons. Okay, this is the leakage of neutrons. Leakage of neutrons. So some of the neutrons are escaped from the system during the nuclear fission process, that is called leakage of neutrons. Some of the neutrons are absorbed by the neutron absorber, that is called as non-fissionable materials. Non-fissionable material. Okay. So these two factors are lead to the loss of neutrons. Okay. So during the nuclear fission, the neutrons is produced. So this amount is produced neutron amount is more than the rate of loss of neutrons during the nuclear fission. So the fissionable material is equal to a certain optimum value. So this is the critical mass. Okay. So what is meant by critical mass? The production of neutron is more than the rate of the loss of neutron. Okay, so this is the critical mass. Nuclear fission is also a chain reaction because the number of neutrons is produced. So the critical mass is denoted as mc. Okay, so the critical mass is depends on the nature, density, or and the size of the fission material. So the atom bomb we are used termed subcritical mass and supercritical mass. Okay, first what is meant by subcritical mass? If the mass of the fission material is less than the critical mass, it is termed as subcritical. Okay, the fission material is less than the critical mass, that is called subcritical. If the mass of the fission material is less than the critical mass, it is termed as subcritical. The next one is if the mass of the material is more than the critical mass, it is termed as supercritical. So subcritical means that if the mass of the fission material is less than the critical mass. Same for the if the mass of the material is more than the critical mass, that is a supercritical. Okay, so this is the critical mass. So next we have learned about nuclear fusion. So already we know that the heavier nucleus split into two smaller nucleus, that is nuclear fission. Nuclear fission means that the two lighter nucleus combine to form a heavier nucleus, that is nuclear fusion. Okay, this is the difference between the nuclear fission and the nuclear fusion. Okay, nuclear fission means that the heavier nucleus splitted into two smaller nuclei. The nuclear fusion is a two lighter nuclei to form a or combine to form a heavier nucleus, that is nuclear fission. For example, hydrogen 1 H2 plus 1 H2. These are the two lighter nuclei to combine a form a heavier nucleus, that is 2 helium 4, and amount of energy is released. Okay, so this is the explained in the picture form. Okay, so 1 H2 plus 1 H2 gives it 2 He3 plus 0 N1 plus energy. So already we know that the process of fission there are daughter and parent nucleus is formed. So the mass of the daughter nucleus is formed at the nuclear fusion or nuclear fission. The mass is less than the sum of the masses of the two parent nuclei. So this difference in the mass is called mass defect. Okay. So the daughter nucleus mass is less than the sum of the masses of the two parent nuclei. So this difference is called as mass defect. So this mass is converted into energy. So this concept is proposed by Einstein in 1905. The famous equation is E equal to mc square. So c is the velocity of light in vacuum or air. It is equal to, that is c equal to 3 into 10 power 8 ms power minus 1. Okay. So this is the nuclear fusion. Nuclear fusion means that two lighter nuclei coming to form a heavier nucleus, that is nuclear fusion. So what are the conditions necessary for the nuclear fusion? So nuclear fusion means that two lighter nuclei comes to form a heavier nucleus, for example hydrogen. So the Earth atmosphere contains a hydrogen. So spontaneously the nuclear fusion is happened. Why this explosion can't happen in atmosphere? Because the nuclear fission is happen during the extremely high temperature of the order of the 10 power 7 to 10 power 9 Kelvin. Okay. So high temperature and high pressure, the nuclear fusion is happened. So the nucleus, hydrogen nucleus fused and close to the two nuclei, and the nuclear fission is happened. So this is called as a thermonuclear reaction. Okay. At the high pressure and high temperature, push the hydrogen nuclei to close and fuse with each other. So this term is called as a thermonuclear reaction. At what temperature? 10 power 7 to 10 power 9 Kelvin. At that time, the hydrogen nuclei closer to the fuse and close to each other. So this process is called as thermonuclear reaction. Okay. This condition, the nuclear fusion is happened. So the unit starting, there are nuclear fission is two types, that is natural and artificial. The nuclear fission is also a artificial radioactivity, but the nuclear fusion is natural and artificial. So natural nuclear fission is the stellar energy. The artificial nuclear fusion is the hydrogen bomb. Okay. So stellar energy. So the stars like our sun emit a large amount of energy in the form of light and heat. So this energy is termed as the stellar energy. All of you know that the sun is emitting radiation. So same for this, like that stars have a amount of energy. So that energy is called as stellar energy. So the stars contain a hydrogen gas. Okay. So how do the sun have a heat and light energy? Same for the stars outer surface, very hot. Okay. Very hot or heat. So which time the nuclear fusion is happened? High temperature. Okay. So the sun and star like a very hot and high temperature. So at that place the nuclear fission is happened. the inner side of the sun, the nuclear fusion is happened. So this process is called as stellar energy or nuclear fusion or thermonuclear reaction. So these are the sources of light energy, heat energy. So this is called as a thermonuclear reaction or nuclear fusion or stellar energy. Okay. So the next type is hydrogen bomb. So this is the artificial nuclear fusion. Okay. So the hydrogen bomb is based on the principle of nuclear fusion. Okay. But the atom bomb is principle is based on the nuclear fission. Hydrogen bomb principle is nuclear fusion. Hydrogen bomb nuclear fusion. Atom bomb nuclear fission. So the energy released in a hydrogen bomb is much higher than that released in an atom bomb. Okay. When the hydrogen bomb is exploded, then we are used to the atom bomb. At that time, the hydrogen fusion is happened. Next, the hydrogen bomb is exploded. So that time the energy is released. It is very high than the atom bomb. Okay. So this is the hydrogen bomb. So we are now learned about nuclear fission and nuclear fission. So what are the features of nuclear fission and nuclear fusion? The first nuclear fission. The process of breaking of the heavy nucleus into smaller particles smaller nuclei is called as nuclear fission. It is opposite to the nuclear fusion. Nuclear fusion is the combination of two lighter nuclei to form a heavier nucleus. Nuclear fission can be performed at room temperature, but nuclear fusion is extremely high temperature and high pressure is needed. Nuclear fission alpha, beta and gamma radiation are emitted. Alpha rays, positrons and neutrons are emitted. Fission leads to emission of gamma radiations. This triggers the mutation in the human gene and causes genetic transform disease. Only light and heat energy is emitted. So these all points are we are discussed in the nuclear fission and the nuclear fusion already. Okay. So first nuclear fission, heavy nucleus divided into two smaller nuclei. Nuclear fission, two smaller nuclei combine to form a heavy nucleus. So nuclear fission is happened in the room temperature, but in nuclear fission high temperature and high pressures. For example, sun and stars. Inside the sun and stars, the nuclear fission is happened. So at this process, nuclear fission process, alpha, beta, gamma radiations are emitted. The nuclear fusion, alpha rays, positrons and neutrons are emitted. Okay. Nuclear fission emit the gamma radiation. So this gamma radiation affects the human being, also affect the genes. So என்ன சொன்னேன் ஏற்கனவே அது ஜீன்ல பாதிக்கும் அப்படின்னு சொன்னா fourth point வந்து அதான் கொடுத்துருக்காங்க. ஓகே. So nuclear fission, only light and heat energy is emitted. So these are the nuclear fission and nuclear fusion emission. Already we learned about nuclear fission. There are two types of nuclear fission, controlled chain reaction and uncontrolled chain reactions. So the nuclear reactor is based on the principle of controlled chain reaction. So we learn about nuclear reactor. So nuclear reactor is a device. in which the nuclear fission reaction takes place in the self-sustained and controlled manner in produce electricity. So first the nuclear reactor is built in 1942 at Chicago, USA. Okay. So there are many types of nuclear reactors, that is breeder reactor, fast breeder reactor, pressurized heavy water reactor, pressurized water reactor, boiling water reactor, water cooled reactor, gas cooled reactor, fusion reactor, and thermal reactor. So these are the types of nuclear reactor. So these are the nuclear reactor are used in the worldwide. So what are the components are used in the nuclear reactor? That is a fuel, moderator, control rod, coolant, and production valve. So fuel. A fissile material is used as the fuel. The commonly used fuel material is uranium. Okay. So this is the nuclear reactor picture. This is the moderator, fuel, rod, coolant. Okay. This is the water and this is the heat exchanger and water outside and water inside, and this is the reactor core, and this is the this long rod is controlled rod. Okay. So these are the streams are outside and this is the dynamo and transmission. This is the nuclear reactor picture. So some of the fission material is used as the fuel. So commonly we are used in the uranium. Okay. So the uranium nucleus is produce the three neutrons and some of the neutrons are absorbed. So uranium is used as the fission material and it is used as the fuel. So next component is moderator. So this moderator is used to slow down the high energy neutrons to provide a slow neutrons. So most of the moderator used as the graphite and heavy water. So these are the used as a moderator, graphite and heavy water. So this moderator used to slow down the high energy neutrons. Okay. So the next one is control rod. So this rod are used to control the number of neutrons in order to have sustained chain reaction. So cadmium and boron rods are used to control rods because these are the absorb the neutrons. Already we know that the absorbing neutrons. So which one is absorbing the neutrons? Boron or cadmium rods. So these are the used as the absorbing neutrons absorber. Okay. So the next one is coolant. So it is used to remove the heat energy in the reactant core. So these are the reactant core. So this coolant is used as the remove or leave the heat. So the steam is used to run a turbine in order to produce electricity. Water, air, helium. So these are the coolant agents. Okay. So the components are used to maintain a nuclear reactor. Okay. So next one is production valve. So production valve is a thick concrete lead valve. Okay. Already we know that What are the preventive measures for the radioactivity? We are used to the lead coat or gloves. So the productive wall, nuclear reactive productive wall is also used as the lead wall. Okay. So it is prevent the radiation, harmful radiation escaping into the environment. Okay. So this lead wall protect or prevent the harmful radiation from escaping into the environment. Suppose this harmful radiation escape from the nuclear reactor, it is affect the that place, living organisms, etc. Okay, so we are using the lead wall in the nuclear reactor. Okay, so what are the components of the nuclear reactor? Fuel. So uranium is used as the fuel. Next one is moderator. So graphite and heavy water, these are used as the moderator. Next one is control rod. So boron and cadmium rod are the used as the control rods. These are the absorb the neutrons. Okay. Next one is coolant. So water, air, helium, these are the coolant agents. Next one is production wall. Yeah, concrete lead wall is built in a nuclear reactor. So this wall is prevent the harmful radiation escaping into the environment. Okay. So next, what are the uses of nuclear reactor? So nuclear reactors are widely used in power generation. They are also used to produce radioisotopes which are used in variety of applications. Some reactors help us to do research in the field of nuclear physics. Breeder reactors are used to convert non-fissionable materials into fissionable materials. So these are the uses of nuclear reactor. So first point is power generation. We are using the electricity. So this power used in the nuclear reactor. Okay. So nuclear reactor is used in the power generation. Next one, they are also used to produce radioisotopes which are used in variety of applications. Already we learned about radioisotope uses. So the radioisotope used in the medical field, agriculture, research center, etc. The radioisotope is used. So this radioisotope is production in the nuclear reactor. Okay. So some of the nuclear reactors is used to research field in a nuclear physics. Okay. So breeder reactors. We are discussing the nuclear reactor, but there are many types of reactor. So one of the breeder reactor is used to fissionable non-fissionable material converted into fissionable material. So these are the uses of nuclear reactor. The next one is nuclear power plants in India. In Asia and India, Apsara is the first nuclear reactor. Okay. So in India, there are 22 nuclear reactors are operating. Cyrus, Durva, Purnima. These are the some other operating reactors. Okay. So in 1948 August month, the Indian Atomic Energy Commission was established in the Department of Scientific Indian Scientific Research Committee at Bombay in Maharashtra. So this is the agency for all the research done in the field of atomic energy. The chairman of the Atomic Scientific Research Committee in Dr. Homi Jahangir Baba. He was the first chairman of the Indian Atomic Energy Commission. So this center is known as the Baba Atomic Research Center now. Okay. Now this called as the Baba Atomic Research Center. So nuclear power is the fifth largest source of power in India. So Tarapur Atomic Power Station in is India first nuclear power station. So there are totally 7 power stations in one each in Maharashtra, Rajasthan, Gujarat, Uttar Pradesh, and 2 in Tamil Nadu. That is Kalpakkam and Kudankulam. These are the nuclear power station in Tamil Nadu. Okay, so Unit 6 is over. Nuclear physics is over. So 10 lessons are completed, remaining 1 lesson carbon and its compounds. Future classes we will discuss about carbon and its compounds. So in this class we have learned about what is mean by nuclear fusion, atom bomb, hydrogen bomb, stellar energy, etc. Nuclear reactor. What are the components of the nuclear reactor? These are the we are learned in this class. Okay. Thank you, student.